So my name is Ellen Welch. I have been at PTC for about 18 years. Before that, I was getting my PhD at the University of Massachusetts Medical School. And there I worked on nonsense mutations and how they affect gene expression. So to come to PTC was sort of a logical progression in my career. So a nonsense mutation, I think what you first have to understand is that all the genetic information in the cell is encoded in DNA. You make a copy of DNA into RNA, and then RNA is the template that the cell uses in order to make a protein. So when you have a nonsense mutation in a gene, so if you take the DMD gene, for instance, and you get a point mutation in DMD, when that DNA is copied into RNA, that point mutation can now be part of the RNA that becomes what's called a premature stop codon. So this is what Anakin has. He has a premature stop. So what does that mean? It means when the cell uses this piece of RNA to make a protein, that it cannot make a full-length protein because it has this premature stop signal. It's got a signal in the cell that says stop making the protein, and that signal is in the wrong place. And what dystrophin does is it links the membrane of the muscle to the inside of the cell. It acts as like a shock absorber. So when you walk, your muscle cells don't break open. So when you only have one part of dystrophin, it can't make that link. So if you can read through the premature stop, now you can trick, what Ataluren does is it tricks the cell. And it says, don't stop there, keep going. And then you can make the full-length protein. So now you can link the inside and the outside of the cell together, and that helps to stabilize the muscle. So what we know from what Ataluren does is when you translate, encounter the premature stop codon, the cell machinery is able to insert another amino acid, one of the building blocks for a protein there. So when it inserts that building block, then it can go on and make the rest of the protein normally. It just has to get through that one little hurdle. But that hurdle is a component of the cellular machinery that's very highly regulated, because it's important for the cell when it really comes to the normal stop signal to stop. Otherwise you'll make these weird proteins in the cell. It could be very toxic. So you have to overcome this sort of desire of the cell to stop there. So Ataluren does overcome that. It doesn't restore it to a wild type level, but we think it restores it enough to stabilize the disease, and that's what we've shown in our clinical trials to date. So it just tricks the cell a little bit to make a full-length protein. I think it's very optimistic. I think that there are a lot of companies who are making drugs for DMD now. I think there's Ataluren for the read-through population. I think there's exon skipping that's coming. Other people are working on things other proteins that you could upregulate to replace dystrophin, like utrophin. They're doing that. So I think there's a lot of, there's a nucleus of people that are basically working from many different directions to identify treatments for DMD. So I think it's pretty optimistic, even for kids now. I think it will just get better, but I think I'm fairly optimistic.